All right, so we have another lesson here for this week. We're going to continue our work with thinking through greatest common factor as we learn a second method called grouping. Okay, again, I would ask that you have some paper and a pencil or something to write with to jot down some of these things so you can go through these with me as I model these questions to you, and then there will be some practice for you to do on this topic. Okay, so I am going to recap the factoring by greatest common factor, or GCF. That was the first lesson for this week, and I'm going to do that because we're going to be using that thinking of getting that greatest common factor as we look through some notes or some new work with factoring by grouping. Okay, and then I will explain the practice that I want you to do. So just to review GCF here, remember that GCF is finding the greatest common factor. Okay, meaning we're dealing with those factors, the numbers that multiply to get us that. They have to have every term has to have that in common, and we're finding that largest. Okay, what does our answer to a factoring problem look like? Remember, when we take out that GCF, we put it outside a set of parentheses. So, for example, if like 5 was my GCF, I'd put that 5, and then I would have that set of parentheses, and whatever's left, you know, maybe like 2x plus 7, I would put inside the parentheses. So there's what my answer looks like to this type of factoring problem. Something out front for of a parentheses, like a distributing problem. Okay, and how can I check my answer to make sure it is correct? So if you do get something like 5 times 2x plus 7, you know, you'd want to distribute that out. And here you get 10x plus 35 and hope that that was what you were given as your original problem. Okay, so just to kind of review that here then, to show you a few problems to get thinking back through greatest common factor, I'm going to look at 28 and 36, and I want their common factors. Okay, so when I think about this, you know, when I see 36, I think 6, but 6 doesn't go into 28 evenly. So I have to think of some other factors. Some other factors of 36 are 4. So yes, 4 goes into 28. So their GCF here is 4. So I'm going to take that out. They do not have a K in common because this term does not have a K. Okay, so I'm going to divide both of these terms by 4. Negative 28 divided by 4 is negative 7. The K stays there because we didn't deal with it. And then plus 36 divided by 4 is 9. So there is that final answer. Okay, moving on to another one. 20k to the 6 minus 15k. So first looking at just the 20 and the 15, they have 5 in common. Okay, and then looking at the k's, remember this 6, the exponent of 6 here means that there are 6 k's for that. Okay, and then this one just has 1 k. So how many do they have in common? Well, they only have 1 in common. Okay, so I'm going to take that k out. And then I'm going to set up my parentheses. So each term is going to be divided by 5k. So 20 divided by 5 here is 4. And then k to the 6th power, I'm taking that 1 out. And if you count them, there's 5 left. So I'm going to write k to the 5th. Okay, then negative 15 divided by 5 is negative 3. And there was 1k and I'm taking it out. So it's gone. There's no k's left. Okay, so there is my final answer, 5k times 4k to the 5th minus 3. And again, if I were to distribute that out, I would get back to that 20k to the 6th minus 15k. Moving on to another one here. 24m to the 11th plus 36m to the 8th plus 6m to the 7th. So if I look at those numbers there, the lowest one is 6. 6 does in fact go into 36 and 24, so they have 6 in common. And there's 11 m's here, 8 m's here, and 7 m's here. So remember, we're finding that lowest exponent. So they have 7 m's in common. So I'm going to take out 6m to the 7th. 6m to the 7th. I'm going to divide by that on each term. Okay, so 24 divided by 6 is 4. There were 11 m's and I'm taking 7 out. So I have 4 left, so m to the 4th. Okay, and then 36 divided by 6 is 6, so plus 6. There were 8 m's, and I'm taking 7 out, so there's 1 left. And then plus 6m to the 7th divided by 6m to the 7th. 6 divided by 6 is 1, and m to the 7th divided by m to the 7th is itself, so it's also 1. So because that all kind of cancels out there, I need to write plus 1. So again, if I didn't have that 1 at the end, if I distributed that back out, I wouldn't get that last term. So I want to make sure to have that. So there is the final answer. Okay, remember we can have more than one variable. So looking here, -5, 6, and -10. See, I think of 2 when I look at 6 and 10, but 2 doesn't go into 5. The only factors of 5 are 1 and 5 doesn't go into 6. So looks like 1 is their greatest common factor, but now if I look at the x's, here there are 6, here there are 5, here there are 2. So remember the lowest is what they have in common. So I'm going to take out x squared. If I look at the y's now, this one doesn't have a y, okay? So they do not have any y's in common. So let's see, now we want to look at the y's, and they don't have anything in common, like I said, so we're not going to take any of that out. So the only thing we can take out is that x squared. So I'm going to divide by x squared everywhere. And so -5 divided by, remember there's a 1 in front of all of these, so that's -5. There were 6 x's and I'm taking 2 out, so that's 4 that are left, and we didn't do anything with the y, so that y squared has to stay there. Okay, going on to the next term, 6 divided by 1 is 6. X to the 5th divided by x squared, there were 5, I'm taking 2 out, so there are 3 left. There were no y's there. Okay, -10 divided by 1 is -10. There were 2 x's and I'm taking both of them out, so that's gone, and we didn't mess with the y's, so y squared. So there, that is what is left. So if I distribute that, again, I would get back to that original problem. All right, here, so we're going to be using that thinking and continue on with factoring by grouping. Okay, it is using the greatest common factor information, but if we factor by grouping, we have 4 terms. Okay, so in grouping, we like to break things down, split it into groups. Okay, so what we're going to do is, if you have a polynomial that is 4 terms, and you cannot factor out a GCF out of the whole thing, you want to use grouping. Okay, so there will be 4 terms, and that is the only way that you can use this method of grouping. Okay, sometimes there will be 4 terms and you can take out a GCF, so you won't use grouping. Other times, no GCF for the whole thing, and you'll want to use this method of grouping. So take a look here at this example, and then I will actually do some modeling and show you how you would go about doing this. So here, notice my polynomial here, 2x to the 3rd plus 3x squared plus 4x plus 6, 4 terms. They do not all share an x, and they do not all share that greatest common factor of a number. Okay, so I'm going to split that into 2 problems, and we do that in the middle. So there'll be 2 terms on the left, 2 terms on the right. Okay, then I want to, so now it's 2 problems. I want to do the GCF on the left, the GCF on the right, and then see what I get. So on the left there, the GCF would be x squared. On the right, the GCF would be 2. Okay, so there's the grouping part of it. Now we're going to use the GCF here. Okay, so if I do that, of course, you would do what I did on those problems before. You divide by that. So for the left-hand side, you take out that x squared, and you would end up with 2x plus 3 left. On the right-hand side, you'd take out that 2, and you'd end up with 2x plus 3. Notice that the parentheses match. That means that now there's still a GCF between the 2 problems. So I'm going to factor out that GCF. What do they have in common? Well, they have that parentheses in common. So I'm going to factor that out, okay? And what I have left then is, I factor that out, write that down, and then what I have left is that x squared plus 2, and that's where I put that in the other set of parentheses. Okay, so let's go ahead here and take a look at a few problems. So again, there's no GCF to take out here. Okay, they do not all have a number except for 1 in common, and they do not all share x's. So now I'm going to break it into two problems. And again, we split it down the middle. Always leave that sign that's in front of the third term with the second set so that you can kind of remember that with your problem. Okay, so now on the left-hand side, if I look at this, here's a 1. So 1 and 2, the only thing they share is 1, so that doesn't matter. And I have to look at the x's here. There are 3 and here there are 2, so they have 2 in common. So I'm going to take that out. So divide, by x squared. Okay, so when I divide those two terms by x squared, I had 3 and I took 2 away, I get x plus, and then I had 2 and I took 2 out, so it's canceled, but the 2 is still left there. So x plus 2. Okay, on the right hand side, their GCF is 2, so I'm going to write plus 2, and then I'm going to divide each term by 2. So 2 divided by 2 is 1, but I still have the x. 4 divided by 2 is 2. Again, notice that these parentheses are the same. So now I'm going to factor that out. I'm going to factor x plus 2 out. They have that in common. And if I divide by what they have in common, x plus 2 divided by itself cancels. It changes to 1, so that doesn't matter. So I am left with x squared. Left with x squared here, so I write that in the parentheses, the second parentheses. Okay, these cancel because x plus 2 divided by x plus 2 is 1. And then I'm also left with plus 2, so I write that in the parentheses, plus 2. And there is my final answer, x plus 2 times x squared plus 2. Okay, looking at another one here. So I'm going to split this into two problems. On the left-hand side, their GCF is 5p squared. Okay, so I'm going to divide by 5p squared on both sides. 15 divided by 5 is 3. There were 3 p's and I'm taking 2 out, so I have 1 left. 10 divided by 5 is positive 2. And p squared divided by p squared is 1. Cancels out. It's gone. Okay, on the right-hand side here, new problem. I'm going to put plus. Their greatest common factor is 2, so I'm going to divide both of these things by 2. And I get 3p plus 2. Again, notice they match. That will always happen. If it does not happen, then you did something wrong. Okay, so I'm going to factor that out again. That's what they have in common, 3p plus 2. So I'm going to go back and I'm going to divide by 3p plus 2 on both of those terms. These cancel and I'm left with the 5p squared. These cancel and I'm left with plus 2. Okay, so one set of parentheses here is what they had in common up here on this line. And then this right here is what is left from the GCFs. Okay, so that is the final answer. Okay, moving on to number 3. I'm going to split this in half again. On the left-hand side, when I look at this, 4 and 3, the only common factor that they have is 1. But they do have some v's in common, and they have 2 v's in common. So v squared is what I'm going to take out. So I'm going to divide by v squared on both of these terms. And I get 4v minus 3. Okay, now look at this. This time the second one has a minus, so I'm going to put minus. Okay, between 8 and 6 they have a 2 in common, so I'm going to divide both of these terms by 2. Now here's where we have to be tricky. This is a negative 8 divided by 2. Okay, that I wrote, but I took out a negative 2. I put that as negative, so I need to write this as negative 2 on both those spots, or I will get the signs wrong and it won't match over here. So negative 8 divided by negative 2 is positive 4, which I have over here on the left. My v is left, and then 6 divided by negative 2 is negative 3, and that matches exactly. If I would not have divided by that negative 2, I would have put negative 4v plus 3, which is not the same thing. Okay, so now they have that 4v minus 3 in common, so I'm going to factor that out. And if I divide by 4v minus 3, this cancels, and I'm left with v squared over here. 4v minus 3 cancels, and I'm left with minus 2, so minus 2. So that is my final answer there. Okay, moving on to another one. Okay, so split that in half. On the left-hand side here, their greatest common factor is 2x squared. So if you still have to list the factors, that's fine, like 1 and 4, 2 and 2, 1 and 10, 2 and 5. Oh, the largest one they have in common is 2. Okay, But know that that was explained in the last lesson, so if you need to revisit that video, feel free to go back and click on the link and watch that as well, or go back to the beginning of this video and review greatest common factor. Okay, but I'm going to divide by 2x squared on both of these terms. So 4 divided by 2 is 2. There were 3 x's and I took 2 out, so there's 1 left. Negative 10 divided by 2 is negative 5. And then x squared divided by x squared, that's 1. There were 2 and I took them out, so it's gone. Okay, over here, look what happens here. 2 and 5 don't have a greatest common factor except for 1. So if that happens, you have to put a 1 because I have to put plus a number and have a set of parentheses. So plus 1, okay, so I'm really dividing this by 1, so that means this all stays the same, which that's what I want because if you notice, that matches for the parentheses now. Okay, so sometimes you might just have nothing to take out, but you have to put that plus 1 or minus 1 to help you get that parentheses to be exactly the same as the last one. Okay, so now they have 2x minus 5 in common, so I'm going to divide by that on both sides. And when I do that, I have those GCFs left. So 2x squared plus 1. And that is my final answer there. Okay, moving on to another one. So split it in half. On the left-hand side, their greatest common factor is 2x. So I'm going to divide by 2x on both terms. I get 3y minus 2. Over here, no GCF again, so I'm going to put plus 1. So these are getting divided by 1, so I get 3y minus 2, which, again, that's what I need, because now those parentheses match. So they have that 3y minus 2 in common. Factor that out, or divide by that of what they have in common, and that cancels, and I'm left with that 2x plus 1. So 2x plus 1, and that is the final answer. Okay, number 6 here, split that in half. On the left-hand side, their greatest common factor is 3a. So what I have left when I divide by that is 2z plus 3c. Okay, over here I'm going to put minus. They have 2 in common and they have a b in common. So I'm going to put divided by negative 2b, negative 2b. Okay, and when I divide that here, I get positive 2z. And then when I divide the second term, I get positive 3c. And again, they do match. So they have that in common. So I'm going to factor out what they have in common. And then once I do that, they cancel out. And what I have left are those GCFs out front. So I'm going to write that in the other parentheses, 3a minus 2b. And that is the final answer. Okay, so I would encourage you at this point to pause the video, get a piece of paper, copy these down, try them by yourself, and then after you've tried a few, or if you get stuck or something, continue on with the video so that you can see me go through these and write the answers. But then after that, I will actually ask you to do some practice for a grade. Okay, so this is kind of extra practice here to just kind of help you and me to explain 6 more problems. Then after that, you'll have some practice to go and work on. So again, we're using that GCF concept, but we're splitting this in half and then doing it with each individual problem. And then when we're done with that, they should still have that parentheses as their GCF, and so we can factor that out again. All right, so go ahead and pause the video and try these. All right, hopefully you tried these, and I'm going to go ahead and explain these. So draw the line here to split that into 2 problems. On the left-hand side, their GCF is x squared. And when you divide by that, you get 2x plus 1. Okay, over here, they don't have a GCF. So I see a minus, so I'm going to put that. But then I'm just going to write 1. Nothing else except for 1. So remember, I have to put that. When I divide by negative 1 everywhere, I get 2x plus 1. So now those match. So I'm going to factor that out. So 2x plus 1. And when I divide by that, remember, I get those GCFs that are left. So x squared minus 1. That is the final answer. Okay, over here on number 2, on the left-hand side, their GCF is x squared. So when I divide by x squared, I get x minus 2. Over on the right-hand side, their GCF is 2. So I'm going to put minus since there's a minus and then 2. So I'm dividing by negative 2 on each of those. Which I'm going to go back here and put that I divided by x squared. Sorry. All right, so on the right-hand side, dividing by negative 2, I get x minus 2. And they do match, which is what I want. So I'm going to factor that out. And again, when I divide by that, it will cancel these. And what is left are that x squared minus 2. So x squared minus 2. And that is the final answer. Okay, number 3. Splitting it in half. On the left, their greatest common factor is a squared. You get a minus 3 that's left. On the right-hand side, I'm going to put minus, and then they have a 3 in common. So if you divide by negative 3, you get a minus 3. And again, they match, so I'm going to factor that out. They still have something in common. And those will cancel out, and I have those GCFs left. So a squared minus 3. And that will be the final answer. Moving on to number 4, split it in half. Their GCF is b squared. So when I divide by v squared, I get 2v minus 3. Over here on the right-hand side, I'm going to put a plus sign since that's the sign I see, and they do not have a GCF, so I have to write 1. And when you divide by 1, you get 2v minus 3, which is good because now they match. I can factor that out. When you factor that out, they will cancel, and you will have that v squared plus 1. So v squared plus 1. All right, number 5, split that in half. Their GCF is k squared. So when you divide by that, you get 6k plus 1. On the right-hand side, I put minus. Their greatest common factor is 6. When you divide by that, you're going to get 6k plus 1. Remember there, you're dividing by negative 6. That's how I got that to change to that plus 1. Okay, so again, I'm going to factor out what they have in common, so that matches. So 6k plus 1. And then what I have left, those will cancel, and what I have left is that k squared minus 6. So k squared minus 6, and that is the final answer there. Okay, and the last one here, split it in half. This time they have 5p squared in common. So I'm going to get p plus 1. Over on the right-hand side, I'm going to put minus, and they have 4 in common. Okay, so I'm dividing by a negative 4. So that's how I end up getting the p plus 1. Okay, so they have that p plus 1 in common. So I'm going to factor that out. And again, when I do factor that out, this will cancel and this will cancel, and I have that 5p squared minus 4. So 5p squared minus 4. All right. So if you feel like you are ready, go ahead and go to Canvas. There's a required practice. Look under the quizzes. Make sure you're doing period 2. The e-learning week of March 23rd, number 2, since this is the second lesson of the week and your last lesson for this week. And you can try that quiz as many times as you need. Email me throughout it. If there's one specific one you don't understand, tell me, I don't get number 4 or something like that. They are multiple choice, I believe with 2 options apiece. So it kind of narrows it down. Watch your signs. That's what I would tell you. And there is also an optional practice attached on Canvas. That would be optional practice, factoring by grouping, and not required, but if you need extra practice, want some more problems to look at, the answers are on there so you can kind of check your work. And if you feel like you're not ready for this practice, the required practice or the optional, go back and watch the video again. Maybe go take a break, do something else, come back and revisit it and see if it makes more sense the second time when you watch it. But please email me if you have questions on this. Again, still using that concept of GCF, factoring out what they have in common, but splitting these into 2 problems and then going from there. Have a great day.